Hello students, I am Dheeraj Namdev, working as an assistant professor in AI and ADS department of IIMT College of Engineering, Greater Noida. Today I am going to discuss an important topic of subject computer network, which is random access protocol. So the contents are division of data link layer, then we see multiple access, taxonomy of multiple access protocol, random access protocols, pure aloha, slotted aloha, comparison between pure aloha and slotted aloha. Then we see CSMA and different type of CSMA protocol, then CSMA CD, CSMA CA. So firstly we understand that the data link layer is the second layer in OSI model. Here the responsibilities of data link layer are physical addressing, framing, error control, flow control, access control, and so on. So, out of these responsibility, an important responsibility is access control. So, the access control is provided by a separate sublayer. It is present inside the data link layer. It is called as MAC layer, medium access control layer. It is the sublayer. Now, multiple access. Multiple access, understand this concept by real life example. Suppose there are 10 stations, they want to send their data. Now, the 10 for 10 stations, if 10 separate wire will be provided, then it is very costly. So, for 10 station to send the data, a single channel is provided, a single transmission wire is provided, and each station will get chance to access the transmission wire one by one. So here multiple access means multiple devices are present and they want to send some data, and a single channel is present on which they send the data. So which device will use that transmission channel at a time, it is decided by some protocol. These protocols are called as multiple access protocols, multiple access protocol or media access control protocols. The meaning of this is, if there are n stations, then how it is decided by some protocol, by some set of protocol. We design some protocol which decide which station will use the channel at a particular time. Now suppose more than one station will send the data at a time. Suppose three stations send the data simultaneously, then the data loss will occur due to collision. In physical layer we deal with the data, it is present in the form of byte. In data link layer it is present in the form of frames. In a network layer the data is present in the form of packets. So the better word to use here is, instead of using the word data, we use here the word frame. So it's proper suitable here. So here the frame loss will occur due to collision when more than one station send its data at a time on a single channel. Now the responsibility of protocol should be, it should minimize the collision. Why? It is the responsibility of protocols. We have to design some strategy, some protocols by which the collision will be minimum, so that the data will be transferred successfully to the receiver. And one more thing is that the channel should not be idle. It should not happen the channel is idle and stations are waiting to send the data. It is the wastage of channel, it is the wastage of bandwidth. So the proper utilization of bandwidth is also responsibility to for such protocol. Now this protocol will determine when a station can use the link. 10 stations are present, then how it is decided? It is decided through protocol which station now have chance to send the data. What a station should do when the link is busy? If the link is busy, what the station should do, it should also be properly well defined. What a station should do when it is involved in collision, so it should send the data again, it should send the frame again. Now here there are two factors. First one is throughput and second one is propagation delay. Throughput is the amount of data moved successfully from one place to another in a given time. Means whatever data we send from sender to receiver, it may happen that its frames get lost during the transmission. So the amount of data, the exact amount of data, the actual amount of data that can successfully transfer from source to destination in a given time, it is called as throughput. It is measured in the form of percentage: 89%, 76%, 60%. When the noise is more, when the distortion is more, then the throughput will be less. Second factor is propagation delay. It is the amount of time it takes for the head of signal to travel from sender to receiver. Means when the frames transfer from source to destination, what is the time? What is the time of travel? It is called as propagation delay. It should be minimum. It should not happen that the propagation delay should be high. The data should be transferred in very small amount of time. Now the taxonomy of multiple access protocol is explained through this hierarchical structure. Here we have categorized multiple access protocol into three categories. First one is random access protocol, second one is controlled access protocol, and third one is channelization protocol. Random access protocol contains Aloha, CSMA, CSMA CD, CSMA CA, and controlled access protocol has three protocols, which is reservation protocol, polling, and token passing. And channelization protocol is FDMA, TDMA, CDMA. FDMA stands for frequency division multiple access. Then TDM means time division multiple access, and then CDMA means code division multiple access. In this video we are going to understand about the random access protocol. So we will see in more detail about the Aloha, CSMA, CSMA CD, and CSMA CA. Firstly, understand about the random access. In random access, let us understand this by some examples. Suppose we have 10 stations, then 10 stations should have equal priority. No station is superior to another station and none is assigned control over another. It should not happen one station get uh, uh, supervised over the another station. So it the random access means the station use the channel randomly without any priority. There should be defined some procedure, there should define some protocol. On the basis of that protocol, how the station will access the channel, it is called as random access. They use the channel randomly. And the topic discussed in the sections are Aloha, CSMA, then CSMA CD, and CSMA CA. Firstly, we see about the pure Aloha. In pure Aloha, the station who want to send the data directly send the data. It will not wait. For example, if 10 stations are present and they want to send the data, then they directly send the data without detecting whether the channel is free or not, whether the channel is busy or idle. So we understand in this case there is a maximum chance of collision. Collision happened definitely. Collision happened definitely in this method. So this is called as the pure Aloha. Now here one formula is given here: timeout equal to 2 into T propagation. T prop means propagation time. Now we see how 2 will come. So when station will send the data, it send next frame when it gets its acknowledgement of previous data. For example, when station 3 send some frame, then it will not send next frame until it get acknowledgement from the receiver. So here firstly the frame will send from source to destination, the time is t. It's called as propagation time. And when acknowledgement come back from destination to source, again the time is same, which is a propagation time of acknowledgement. Both time are same. That's why t plus t, that's why 2 will come here to multiply time of propagation. So here, if the acknowledgement not received, it assume that the packet get lost and it resend its frame, है ना. This is the diagram by which we understand about the frames in pure Aloha. Here we have 4 stations and each station is sending 2 frames. Station 1 is sending frame 1.1, station 2 is sending 2.1, 2.2, station 3 is sending frame 3.1 and 3.2 and so on. So here we see during the time in which frame 1.1 is present, in this time no other frame is present. So frame 1.1 will be delivered successfully without any collision. Now see the frame 1.2. During this time, the station 2 send the frame 2.1, station 3 send the frame 3.1 and station 4 send the frame 4.1. So here during this interval the 4 frame will get collision and all frame destroyed. No frame will reach the destination. Similarly, after some time, frame 2.2 get collided with frame 4.2 and frame 3.2. In this interval, no frame exists, so it successfully delivered to the destination. So this is about the pure Aloha. Now the procedure of pure Aloha protocol is explained through this flowchart. Firstly, we start here. K indicate the number of attempt. Initially, the first attempt, so the value of K is 0. Initially, the station will send the frame. After sending the frame, the station will wait for the acknowledgement and then send its next frame. So here the waiting time will be 2 into propagation time. If the acknowledgement is received, then station assume that the frame is delivered successfully. If the acknowledgement not received, it increase its value of k, means second attempt. In first attempt the data loss occur, the acknowledgement is not received, means station will assume that the data loss occur, the frame loss occur. So in second attempt again it send its frame. Now it should not happen that it again and again attempting to send the frame. There should be some limit. So for this the maximum number of attempt is decided and it is normally 15. The station attempt 15 times to send its frame. After this, if the station will not get the acknowledgement, it will stop. So here the value of k is checked, the value of attempt, number of attempt is checked. If it is greater than maximum time, then it aborts its operation. If the number of attempt is less than the maximum number of attempt, then it choose a random number between 0 to 2 raised to the power k minus 1. This is the time. After this it wait for time and then send its second frame. So this is all about the pure Aloha. Now vulnerable time for pure Aloha is, we can understand in this diagram. In this diagram the t is present in the center and t minus t fr is present in the left side, and in the same amount t plus t fr is present. So here the vulnerable time becomes 2 into tfr. tfr is added, TFR is added 2 times, that is you can find the difference between T and T minus TFR, it is TFR, and again the difference between T plus TFR and T is again TFR, so the total vulnerable time will become 2 into TFR. The throughput of pure Aloha is G multiply e raised to the power minus 2g, and it gets its maximum value when the value of g is 1 upon 2. So here we see the maximum throughput is 0.184. When we convert this value, the answer will be 18.4%. It means the channel is not properly utilized, the data loss happen, and there are so many disadvantages. Its value is very less. The channel utilization should be maximum. Here only 18% is utilization, 18% is throughput. So this protocol we generally not use in our daily life. After this, the second protocol is slotted aloha. In slotted aloha, the time of channel is divided into slot, and the length of slot is equal to the frame transmission time. Let us understand this through the diagram. Here this is the slotted aloha. Here the time is divided into different slot, and the length of slot you can see here is the length of frame. So here each station who want to send the data will use the slot one by one. If again at the same time two or more station will use the same slot, will send their frame in the same slot, then the frame loss will occur here. So this is about the slotted aloha. Here the time is divided into different slot, and the length of slot is equal to the length of frame. Here we can see in case of slotted aloha, again we have the case of 4 stations and each station want to send 2 frames. So here we can see the total number of frames is 8, and out of 8 frames 4 frame get lost due to collision. Now the 4 frame get delivered successfully. So here we can see in previous case we have seen only 2 frames delivered successfully, and in this case 4 frames delivered successfully. So it has some better utilization, it has some better throughput as compared to previous pure aloha. The throughput of slotted aloha is g into e raised to the power minus g. In case of previous pure aloha, the value of power is minus 2g. Here the value is minus g. And when we put the value g equal to 1, we get the maximum throughput, and whose value is 0.368. When we convert into percentage, the value will be 36.8, which is approximately 37%. So it is twice. If here we get in slotted aloha, by division of time in different slot, we get twice throughput as compared to pure aloha. Now the vulnerable time of slotted aloha is again decreased. In case of pure aloha, it is twice of transmission of frame time, and in case of slotted aloha, the vulnerable time is equal to transmission time of frame, because here the collision occur in particular slot. So the length of slot is equal to the length of frame, so that's why transmission time is equal to transmission time of particular frame. The time interval of particular frame is equal to vulnerable time. Now, some advantages of Aloha are: a node has frame to transmit it, can transmit continuously at full rate of channel. Those stations who want to send the data, they directly send the data without sensing the channel. They will not check whether the channel is idle or busy, they directly send the data. So it may possible that only one station is present and only one single channel is present. So in this case, no collision happen, and one station will utilize the channel maximum, है ना. It is simple to implement it, no master station is needed to control the medium. So all these are advantages. Here we can continuously transmit the data if only single station is present. If more than one station is present, there will be the chances of collision. This is the disadvantage. So it causes low channel utilization. Here the bandwidth is lost due to collision, due to idle condition. Now we see the comparison of pure aloha and slotted aloha. The frame transmission in case of pure aloha, those station who want to send the data, whatever data they have, whatever frame they have, they directly send the frame. In case of slotted aloha, the channel is divided into different slot, and station will utilize one slot one by one. And the time in pure aloha, the time is continuous, and in slotted aloha, the time is discrete. It is divided into different slot whose length is equal to length of frame. And the throughput is 18% in case of pure aloha, and in case of slotted aloha it is 37%. Its value is 36.8, and which is approximately equal to 37%, so I write here 37%. And its value is maximum when the value of chi is 1. Now in previous protocol, that is aloha protocol, the station who want to send data directly send the data without sensing the medium. If they sense the medium, if they check whether the transmission media is idle or busy, then the chances of collision can be minimized. If 10 station are present and station 6 want to send some data, so before sending the data, it firstly check whether the channel is idle or busy. If the channel is busy, then it wait for some amount of time. When it gets the channel idle, they send its frame so that the collision will be minimized. So this are called as carrier sense multiple access protocol. Carrier sense means here the carrier means transmission media, transmission channel link. It is firstly sensed by station. If it is free, then they send the data. Now here in this diagram there are four stations A, B, C, D. These stations want to send the data. Suppose station A send the data at time t1. So the time is increasing continuously and continuously increasing, and the frame is delivered to the destination. During this time, this time is indicating by yellow. It is the transmission time of a frame by station A. Now when station A sends some data, station B, C, D must wait. When the channel get idle, they will send the data. So here that waiting part is represented by black color. So here if station B will send the data during this black interval, if station C will send some data, then the chances of collision. So station C, station B and station D should wait. After some time, when the channel get idle, they will send the frame. So here the vulnerable time is equal to propagation time. Now different type of CSMA protocol decide what station should do when the medium is idle, what station should do when the medium is busy. There are n station, so every time channel will not free, so it should be well defined what station should do when the channel is ideal. It means they have to send the data, and when the channel is idle, they send the data. When the channel is busy, they have to wait. So it is decided by three methods, which is one persistent, non persistent and p persistent method. Firstly, we understand about one persistent method. Here you can understand this by the diagram. Here 10 stations are present and they want to send the data. Initially they find that the channel is going too busy. They continuously sense the channel. When they get after some time, that is after the colored part, they get the channel is idle, then the station directly send the data. Now it may happen there are n stations, there are 10 stations in this diagram. These station will sense that the channel get idle after some time. So it may possible again that two or more station will send the frame simultaneously. So again here the chances of collision. In this method, when the channel gets idle, it may possible that two or more station will send the frame simultaneously. So again the chances of collision. So it is minimized by some factor in non-persistent method. Here the station who want to send the data firstly sense the channel and check whether the channel is idle or busy. If the channel is busy, it wait by some amount of time. Again it sends the channel, again it get busy, then it wait random amount of time, and then it detect again if the channel is free, they send its data. If the channel is idle, if the channel is busy, they have to wait. If the channel is idle, they will send its frame. So here the waiting time is chosen randomly. In non persistent method, the waiting time of station is chosen by random amount of time. So here this is about the non persistent CSMA. Now in this method again, the when n stations are present, when 10 stations are present and they are continuously sensing the channel, then it may possible that the random waiting time of two station can be same. Initially they wait for 5 seconds, then 10 seconds, then 15 seconds. It may possible that another station have the waiting time, random waiting time, that is 5 second, 10 second, 15 seconds. So in this case again collision can happen. So but the chances of collision you can understand is minimized as compared to one persistent method. So it is resolve this problem is resolved in next method, which is p persistent method. Here the station continuously detect the channel, sense the channel. Here 10 stations are present, and when they find that the channel is idle, they will not send the data, they will not send the frame. They wait for some amount of time, then they send its frame. Just understand, when station find that the channel is idle, then they directly will not send its frame. They will wait some amount of time. After that time, they will send its frame. Now the important thing is waiting time. How it is decided? So it is understand through this diagram. Here in first case, in one persistent method, when station find channel is idle, directly send the frame. When it is busy, it again detect the channel. In case of second non persistent method, the waiting time is randomly chosen. And in third case, when station find the channel is idle, they will not send its frame, they wait for some amount of time. So here you can understand, if the channel is busy, they again continuously sense the channel, and if the channel is idle, then it calculate its probability outcome. And the based on the value of probability outcome, it is decided that the station will transmit the frame or not. So here if the value is greater than p, then it again wait for a time, for a slot. And if the value of probability outcome is less than or equal to p, then it send its frame. Now what is the probability outcome? Probability outcome is, suppose four stations are present, then different probability values is assigned to these four stations. Suppose the probability value 0 0.2, 0 0.3, 0 0.4, 0 0.5. This is the probability of station. When the frame will come, again the probability of particular frame is set, and that value is compared with station probability. When the value is less, then it send its frame. When the value is more, then it wait for a slot. So by this way we understand the collision is minimized by some factor. This is explained in this theory. The value of probability is calculated so that the number of chances of collision can be minimized. Now the next concept is CSMA CD, carrier sense multiple axis collision detection. Then we see carrier sense multiple axis collision avoidance. So how the collision can be detected and how the collision can be avoided, let us see. Here we understand this method by this flow chart. Here in this, initially starting time, the attempt is 0, k indicate the number of attempts. So in first attempt, initially the station will apply any one of the persistent method to check that the channel is busy or idle. After this, if they are eligible for transmission of data, then they transmit the data, transmission done. Or it may happen that the collision will be detected. So if the transmission is done, then in yes case the collision will be detected. Then again, if the collision is detected, then it send a jamming signal. Let us understand this cycle one by one. Firstly, understand when the transmission is done. Again, if the transmission is not done, it again transmit, retransmit. This process, this cycle continuously repeated. If the transmission happen, then it check whether the collision is detected during transmission or not. So if the collision is not detected, it means that the frame is delivered successfully. If the collision is detected, it sends a jamming signal and it increases its value of k, that is it send data, it send frame in second attempt. Now what is the meaning of jamming signal? This method is basically used in wired transmission media. So you know it very well, when two positive voltage combine, then fluctuation happen. The value of voltage will be increased. 5 volt are present on two wire. When both are combined with each other, 10 volt will be generated. So this is the way by which collision is detected. Here, if two or more station want to send the data, then if two or more stations send its frame, then due to collision of frame, some voltage will increases. By detecting that voltage, it is called as jamming signal. That signal will send again to stations back, so that they detect that the frame is collided, frame get collision during the transmission. So by sending the jamming signal, जैमिंग सिग्नल मीन्स दो वोल्टेज जैसे ही बढ़ जाएगा, दो फ्रेम जैसे ही कोलाइड होंगे, तो जो वोल्टेज आएगा after this generating that voltage, it is detected by some device, and then it the message will be passed to the station through the jamming signal. And again the same process repeated here. If the number of attempt is more than maximum number of attempt, then it abort it operation. If the number of attempt is less, then it choose a random number between 0 to 2 raised to the power k minus 1, and then wait some time and then apply one of the persistent method, and this cycle continuously. So this is about the CSMACD. Now here you can see in this diagram, this is energy level diagram. Here the energy level indicates some amount of voltage, suppose it is 5 volt. So during wired transmission, the signal is transferred in the form of voltage. So here the frame transmission, you can see the frame is transmitted during this time, and two frames are transmitted during this time. And when the channel get idle, it is indicated uh, by blank space, and the chance of collision, the time of collision is indicated by red. You can understand the voltage of collision is higher than the voltage of normal signal. So by this higher voltage signal, it is detected that the frame get collided, so it send its jamming signal to the station again. Now here in CSMACD method, it is used for wired transmission, but when we talk about wireless transmission, we cannot use CSMACD, because during wireless transmission, when the collision happen, then the voltage slightly differ and it is not easily detected. So to avoid this, the new method come, which is CSMACA, carrier sense multiple access collision avoidance. This method is especially designed for wireless transmission, because during wireless transmission, when the collision happen between two frames, then the difference of voltage cannot be easily detected. It is very 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 less amount of. So in this method, the station who want to send the data firstly sends the channel and wait for some amount of time. It is called IFS. Full form of IFS is interframe space. And after waiting, it reserves some slot in this contention window. So now we firstly understand about the IFS. The station who want to send data immediately, who want to send data earlier, will sends the channel immediately, so its IFS is less. It gets higher priority and its waiting time is less. So the value of IFS is the time. You can understand by it is a kind of waiting time. So the station who want to send a data later, whose IFS will be more. So after that IFS time, it reserves some slot from contention window based on the factor of binary exponential. Means the station 1 want to send the frame. After IFS waiting time, it it detect whether which slot is free. It use the slot by the power of 2, 2 raised to the power 0. It use the 1, 2, 4, 8, 16, 32, like this. This slot will used by station 1. Similarly, the other station will send the data in this contention window. After this reservation, they send the frame, and the timeout is the time timeout is the time which is needed to detect whether the data is successfully transmit or not. So in CSMA CA, the IFS can also be used to define the priority of a station or a frame. Those station whose priority is high, IFS time is less. Those station whose priority is low, IFS time is more. So if the station find that the channel is busy, it does not start the timer of contention window. It stop the timer and restart when the channel become idle. So it is explained through this diagram. Initially in first attempt, it is detected whether the channel is idle or busy. If the channel is free, it will not send the data immediately. It wait a random amount of time, that is IFS time. It is decided by administrator. What is the IFS time of particular station? It decided by administrator. If after IFS time it detects that the channel is still idle, then it choose a random number between 0 to 2 raised to the power k minus 1 from the contention window and wait for R slot. The waiting time will be in the form of 2, 1, 2, 4, 8, 16, and so on. After that waiting time, it find again if the channel is idle, then it send the frame and wait timeout, and they wait for the acknowledgement. If the acknowledgement is received, it means the successful transmission of frame. If the acknowledgement is not received, then the value of attempt is increases by the factor of 1. And again the same thing here, the number of attempt is checked. If the number of attempt is more than 15, then it abort it operation, otherwise it resend its frame. So this is all about CSMA protocol. Thank you all.